Next panel is about what to expect from the next Bitcoin improvement. What are the next steps at technological level? So for that talk, we have a John Newberry. Please give him a warming welcome.
Okay.
John, the stage is yours. Thanks so much to join La BitConf 1 year
Thank
more.
you.
And we leave with your presentation.
Thank you very much. Hello, everyone. My name's John. I am a Bitcoin protocol developer. I've been working on Bitcoin Core for around 5 years now. And 2 years ago, Rodolfo was kind enough to invite me to La BitConf in Uruguay to talk about a future consensus change called Schnorr Taproot. And I'm very happy to say I can't talk about that as a future consensus change because it happened 6 days ago, and we now have Schnorr Taproot in Bitcoin. I obviously didn't do a terrible job in Uruguay because Rodolfo was kind enough to invite me back to talk about future consensus changes in Bitcoin in 20 minutes. So consensus changes are cool, right? Everyone loves consensus changes? Okay, maybe not. Hopefully by the end of this talk, you'll think maybe consensus changes aren't so cool. All right, so like I said, I'm a protocol developer for Bitcoin, and I'm going to try and give you all a sense of what I think about, or what protocol developers think about, when they talk about consensus changes in Bitcoin. When I'm working on Bitcoin, in my mind, I'm always thinking about the thing that I want to build, what I want to put into the world. And that is a system where anyone in the world can store value, right? That's what Bitcoin is. And anyone in the world can transfer value. This is the system that we're trying to build. And on top of that, no one in the world, no government, no company, no actor can compromise that value, can corrupt it. And by that I mean debase the currency or arbitrarily steal funds, withdraw funds from people. And also no one can censor transactions. This is the system that I want to build. This is the system that Bitcoin protocol developers want to build. And there are some very critical properties to money that can make a system like that. It has to be private, and it has to be fungible. Because if it's not fungible, then a central actor could censor certain kinds of transactions, or censor individuals, or censor groups. It has to be scalable, because like I said, I want to build a system of money that can be used by anyone in the world. So it has to scale to billions of users. It needs to be decentralized, because if there's a central point of control, money can be taken, debased, censored. And I want people to take this away today, that it has to be incentive compatible. And this is a critical property of Bitcoin. Here's a quote for you. This adds an incentive for nodes to support the network. The incentive may help encourage nodes to stay honest. He, the miner, ought to find it more profitable to play by the rules. Does anyone know who said this or wrote this? Satoshi, si. This is from the Bitcoin white paper. And part of Satoshi's genius was he realized that if he wants to create a decentralized, censorship-resistant money, it had to be incentive compatible. And I'm going to keep talking about incentive compatibility because I think it's really important. Satoshi built a system that he didn't control, right? He's not the CEO of Bitcoin, and he left after 2 years. And the only way that such a system can exist and can continue to exist without a central controller is that it must be incentive compatible. The users of the system must be incentivized to continue the system and do what's good for the system. So it's really, really important. And as a protocol developer, we can't create features and force users to use those features. Those features must also be incentive compatible. So that's what I'm going to talk about today. And let's drill down a bit more into that, what that incentive compatibility means. It means that what is good for the person making the transaction is good for the node operator. Okay? If we made a feature where what was good for the transactor was not good for the node operator, was not good for the network, we would have a tragedy of the commons. Everyone would use that feature, it would cost more to run a full node, and we would lose decentralization. And one of the key mechanisms for incentive compatibility is the scarcity of block space, right? We only have 1 virtual megabyte every 10 minutes for transactions. And if there are more transactions in space, you must pay through transaction fees to have access to that block space. So if you put less data through the blockchain, you pay less, and if there's less data, it's more private, and the system is more scalable. Incentive compatibility matters. Okay, so before I talk about the future, let's quickly go back over some past consensus changes. In 2012, there was a consensus change, a soft fork, called P2SH, Pay to Script Hash. Prior to Pay to Script Hash, when you create a transaction and your transaction outputs, within that transaction outputs, you specify conditions of spend. So you might say, Bob can spend this output. We don't actually say Bob, we say this public key can spend this output. And then to spend it, you provide a signature. P2SH changed that slightly. The script stopped being in the output, and instead we commit to the script. So we give a hash digest of the script in the output, and then when you spend it, you provide the script. So you're moving that script from the output to the input that spends it. Now, that might not sound like much, but it means, it's really important because it means that if you're running a full node, you need to store all of the unspent transaction outputs. We call those UTXOs. And the UTXO set, the set of all UTXOs that exist in the world, is one of the biggest costs of running a full node. So if we can shrink that by changing from scripts to small commitments, we reduce the cost of running a full node, more people can run full nodes, and we have decentralization. So this is good for users because it allows these new features, but it's also good for node operators and good for the network. And there's another bonus. It hides those spending conditions until the spend. So that's not perfect privacy because they will eventually get revealed, but it might be good for fungibility because if a cartel of miners is trying to censor a certain kind of output, it's indistinguishable, right, until it gets spent. So not perfect, but an improvement. And we can see that this is the, we've got time along the bottom, and the percentage of Bitcoin held in P2SH outputs. We can see from 2014, it starts going up from 0 up to around 30, 35%. So good for users, they started using it, and then it kind of dips off. The reason it dips off is not because it stopped being good, it's because we added something better called segregated witness in 2017. Now, the big thing about segregated witness is it fixes a problem in Bitcoin called transaction malleability, or TXID malleability. And that is where, if I create a transaction and I sign it, the identifier for that transaction contains all of that data, a hash. So if the signature changes, that identifier changes. With SegWit, that signature is separated, so the TXID cannot be malleated. This is incentive compatible because we give a discount to the witness, and so that the input, the signature for that transaction is discounted, it's cheaper than the output. Now, this is incentive compatible because we want those outputs to be small, we don't want the outputs to be large, we can make the inputs large, but the outputs small. And critically, what SegWit allows is chains of off-chain transactions. So in Lightning, the way Lightning works is Alice and Bob put, let's say, 1 Bitcoin each into a UTXO, an unspent output, and then off-chain they can change the balance between themselves. So Alice has half a Bitcoin, Bob has 1.5, and then they change it. And those transactions don't end up on the blockchain, not all of them. For that to work, the TXIDs, those things that used to be malleable, cannot change. Otherwise, that chain breaks. So segregated witness allows this model where we can share UTXOs between multiple people. And that allows Lightning. And Lightning is good for scalability. And it's good for privacy because you're keeping data out of the global ledger. This is a graph of SegWit usage from 2018 through to 2021. 0% before it was activated, obviously, up to around 80% of payments now use SegWit. So it's good for users are using it. It's good for the network, win-win, incentive compatible. And then in 2021, about a week ago, another soft fork was activated called Schnorr Taproot. Now, Schnorr Taproot's great for privacy and scalability again. One of the reasons is that Schnorr signatures, the new kind of signatures introduced in this soft fork, allow multi-signature and threshold signatures to appear like a single signature. So traditionally, before this, if I wanted to do a 2 of 3 multisig, my output would contain 3 public keys, and then the input that spends that contains 2 signatures. That's not very good for privacy, because everyone in the world knows that I've done a 2 of 3 multisig. With Schnorr Taproot, we have multi-signatures and threshold signatures that look exactly like one public key, one signature, indistinguishable. All of that happens off-chain, no one knows about it. That's really good for privacy, and it's really good for scalability because there's less data on the blockchain and less computational requirements for full nodes. Another advantage of Schnorr Taproot is, like P2SH, like P2SH, the conditions of spend are hidden when you create the output. But unlike P2SH, they're also hidden, in most cases, when you spend that output. So you can have an arbitrarily complex tree of different requirements to spend an output, and almost all of the time, on the blockchain, it looks like a single signature. Good for privacy, good for scalability, good for the user, good for the network, incentive compatible. Another thing that's good for the network is that with Schnorr signatures, if you have a bunch of signatures, 10, 100, you can validate them together using less computation than if you were doing them one at a time. This is called batch validation. And again, it's good for scalability because it brings down the cost of running a full node. Okay, so that's the past. I hope you're seeing a bit of a theme here that what's really important is incentive compatibility. So I'm going to very quickly talk about the future. I just talked about multi-signature. Now I'm going to talk about a potential future change called signature aggregation, which is similar but slightly different. So imagine I have a transaction with 3 inputs and 3 outputs. Today, if I want to create that transaction, I need a signature on all of those inputs, right? I need to prove that I'm allowed to spend those inputs. With signature aggregation, we can have the same transaction and a single signature across all of those inputs. So that's nice because there's less data on the blockchain, less computational resources to verify. But what's really interesting about signature aggregation is that it incentivizes different behavior for the users. And one way that it may incentivize different behavior is that this one on the right could be a coin join, right? So a coin join is where different people own these inputs. With signature aggregation, it is cheaper to do a coin join than to do a transaction by yourself. So it incentivizes behavior that is privacy preserving. Privacy preserving for the people using that transaction, and by extension, privacy preserving for the entire network. Incentive compatible. Another potential future change is a proposal called sighash any prev out, previously known as sighash no input with some slight changes. And what you see here is a chain of transactions in a Lightning channel. So you have a setup transaction, and then you have a bunch of commitment transactions. Now, currently with Lightning, as you move through those states, as you move through those commitments, you need to keep hold of all of that data because your counterparty could broadcast one of those old states at any time, and you need to be ready to counter that. With sighash any prev out, the most recent transaction in that chain of off-chain transactions can rebind to any of the previous transactions. So you don't need to keep around all of that old state. I'm not going to get into all of the details about how we do sighashes, but essentially what this means is it's easier to create Lightning, like to do Lightning and to do extensions to Lightning, to have similar off-chain contracts. It just makes the whole model much easier to reason about, and we can hopefully have more complex scripts, more complex contracts off-chain. Next up is a proposal called delegation in general, and there have been actually multiple proposals. The first is Graftroot. That was proposed by Greg Maxwell shortly after he proposed Taproot. And then generalized root, or Groot, and then entroot. Apologies to any copyright holders for any of these images. The idea behind delegation is, with Taproot, I can create an output that has a tree of complex spending conditions, but I need to create that tree upfront when I create that output. With delegation, I can add additional spending conditions if I give a signature after that output was created. Again, I'm not going to get into the detail, but this allows much more complex off-chain contracts again. So hopefully you're seeing a theme here that if we can take data off-chain and create off-chain contracts, we're helping with scalability, we're helping with privacy. And the final proposal I'm going to talk about is covenants. And again, this is multiple covenants. There's been one called OP-CTV, OP-TAPLEAF update verify, TLUV, OP-CheckSig from Stack. They all come down to essentially the same idea. In law, a covenant is a condition on a lease or a deed that prohibits certain behavior. For example, I may have a lease for a house, and there's a covenant that says I'm not allowed to raise pigs on this land. That covenant may also include a clause that says, if I sell this house, I also need to include that covenant. And so it runs through all of the owners of that property. Now, how does this apply to Bitcoin? Well, currently in Bitcoin, if I create an output, I attach spending conditions to that output. So I might put Bob's public key in the output, and that signifies Bob can spend this output if he provides a signature, and then once he has that signature, he can use that output to fund whatever transaction he wants. A covenant would attach conditions to what Bob can do with that output. So I could say Bob is allowed to spend this output if, in the output for that transaction, he sends it to Charlie. Right? That's a contrived example. Why is it important for Bitcoin? Because this allows, again, much more complex off-chain shared UTXO models. In Lightning, we had a UTXO that was controlled by Alice and Bob, and they can rebalance the funds within that UTXO off-chain. With covenants, it should be possible to create a UTXO that's shared by Alice, Bob, Charlie, Dave, Eric, and 100 other people, and rebalance within that UTXO off-chain and have very few transactions on-chain. There are other applications of covenants. Vaults is another application. But again, the idea is if we can add functionality off-chain and take data out of the blockchain, use that simply for settling and for dispute resolution, we have a scalable and private system. Okay, so in conclusion, we, as protocol developers, provide tools. Schnorr Taproot is a tool. No one's using it yet, or very few people are using it, but it's there. And those tools that we provide must be incentive compatible. They must be good for the user that's using that feature, and they must be good for the network. And once those tools are available, application developers can use those tools, wallet developers, exchange developers, and so on. And users benefit when those application developers use those tools, for multi-signature with Schnorr, for example. And finally, users must demand those products, right? It's all about incentives. And so if you want to see Bitcoin scale, you should demand from your wallet, from your exchange, that they use Lightning, that they use Taproot, that they use SegWit, and so on. Bitcoin belongs to the users. Remember that. Okay, that's all I have for you. Thank you very much.
Thank you, John. You know I really appreciate you.
Bueno, come here.
Well, don't leave because, no, you leave now, but don't go away, yes, because I'll need you for another panel. Well, now you can.